Hello and welcome to Earthquake Tip number 15. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor CVR Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure or building we design or build must be earthquake resistant. This earthquake tip number 15 will explain you yet another earthquake resistant measure for masonry buildings, that is vertical reinforcement, and why is it required in masonry buildings. You already know that horizontal bands are provided in masonry buildings to improve their earthquake performance. As you can see in this figure, these bands include plinth band at the plinth level, lintel band at the lintel level, and roof band at the roof level. Despite of these horizontal bands, masonry buildings are weakened by the openings in their walls. During earthquake shaking, the masonry walls get grouped into three subunits as shown in this figure. The masonry above lintel is spandrel masonry, below sill is sill masonry, whereas in between lintel and sill is wall pier masonry. Now let's consider a hip roof building as shown in this figure with two window openings and one door openings. As you can see, it has a lintel band and plinth band as well. Since the roof is hipped one, a roof band is also provided. When the ground shakes, the inertia force causes the small sized masonry wall piers to disconnect from the masonry above and below as shown in this figure 2b. These masonry subunits rock back and forth, developing contacts only at the opposite diagonals. The rocking of these masonry piers can crush the masonry at the corners. Rocking is possible when masonry piers are slender, that means openings are large and weight of the structure above is small. Otherwise, the piers are more likely to get diagonal, that is X-type shear tracks as shown in this figure 2c. This is the most common type of failure in masonry building. Let's see now this figure number 3, which shows unreinforced masonry building. The cross-sectional area of masonry wall reduces at the openings. During strong shaking, buildings may slide under the roof or below the lintel band or at the sill level. Sometimes building may also slide at the plinth level. The exact location of sliding depends on several factors such as building weight, earthquake-induced inertia forces, size and area of openings, and type of door frames, etc. The vertical reinforcement helps prevent this sliding, which will be explained to you now. As you can see in this figure 4, embedding vertical reinforcement bars in the edges of wall piers and anchoring them in the foundation at the bottom and in the roof band at top forces the slender masonry pier to undergo bending instead of rocking and sliding. In wider wall piers, the vertical bars also enhance their capability to resist horizontal earthquake force and delay diagonal, that is X cracking. Adequate cross-sectional area of these vertical bars also prevents the bar from yielding. Further, the vertical bars also help protect the wall from sliding as well as from collapsing in the weak direction. Now let's see this figure number 5. The sliding failure, as explained you now, is rare even in unreinforced masonry building. However, the most common damage observed after an earthquake is diagonal axe cracking of wall piers and also inclined cracks at the corners of door and window openings, as shown here in this figure 5A. When a wall with opening deforms during earthquake shaking, the shape of opening distorts and becomes more like a rhombus, means two opposite corners move away and other to come closer, as you can see in this figure 5A. Under this type of deformation, the corners that come closer develop cracks. If opening size is larger, the cracks are bigger. The steel bars are provided in wall masonry or around the opening restrict these cracks at the corner as shown in this figure 5B. Therefore, always remember lintel and sill bands above and below openings along with vertical reinforcement adjacent to vertical edges provide protection against the type of damage as I explained you in this tip, that is rocking, sliding and diagonal cracking. And also it is a good practice to confine masonry with bands and vertical reinforcement in and around openings. This is all about earthquake tip number 15. You can download this tip from www.bmtpc.org. The next earthquake tip number 16 will be on how to improve seismic behavior of stone masonry buildings. Thank you.